Alright, so right here is a exponential function, and we're going to solve this equation. So what we're going to do is actually, if you remember from Algebra 1, PEMDAS, remember from Algebra 1 you're trying to solve for the x? Well, before we can do x, we have to be at e, or the exponent. So before we can even think about doing this, we have to do what's in front of us, the MDAS, or multiplication, division, addition, or subtraction. So as you can see right here, we have this 3. So we're just going to go ahead and get rid of it. So we're going to subtract 3, and this is going to cancel, and you're going to end up getting 2 to the x equals 40, not that, 39. Alright? So now we're going to do something called taking the log, which is where we're going to put log, and we're going to take the base, which is this number right here. No matter what number it is, this will always be your base. So it'll be base of 2, and we're going to put the log base of 2 on this side. So this is going to cancel out, and you're going to get x equals log base of 2 to 39. Now, you can plug this into a calculator, or if you don't have one, you can do something that we call change of base, where we're going to put log of 39 divided by log of 2. Now, either of these are acceptable to leave, but sometimes teachers would prefer for you to solve this. And unfortunately, we did not do this, so yeah, it equals x. Alright?
Alright, so today we're going to talk about taking the logs. What you're going to have to do to solve for x is you're going to have to use the PEMDAS from Algebra 1 and 2, and to get the x by itself, you're going to have to get to the exponent. So you're going to be traveling this way through PEMDAS. So to do this, you're going to have to add, multiply, divide, add, and subtract. Since we don't have any of that, we're just going to go straight to the exponent. Since x is in the exponent point, we're going to have to take the log of both sides. So since this is a 2, and we're going to have to take log of 2 to the x equals the log base 2. Now the reason we use log base 2 is so that the 2 right here will cancel, and so we can get x by itself. Now in this problem, both these will cancel out, and then x will equal 6.
Alright guys, so we're going to solve this complex equation, trying to find x in the exponent. So, like our other videos, we're going to use PEMDAS. So, you know that e is what our goal is. We have to work to it using the multiplication, division, addition, subtraction. So, now we're going to see what all do we have. Now, we have an addition problem, so we have 6, and we have a multiplication problem 3, so we're going to have to use PEMDAS to get rid of them. So, since addition comes first, then we're just going to subtract 6. Cancels out. And you have 3 times 4 to the x equals 21. And we're going to divide that by 3. It's going to cancel out, so then you have, don't want that, 4 to the x equals 7. Now to get rid of the 4, we're just going to do log base 4. It's going to cancel out. So you have x equals log base 4, 7. Now, most teachers would be fine with this, but just so you can have some practice, we're going to do change of base, so log base 7 divided by log base 4, and it's going to get you 1.403. And of course, we used a calculator to help us with this. So, that's it.
Alright, so just like we were talking about earlier with the logs, ln is pretty much the exact same thing, but ln is equal to the log base e. So if you have a problem that has e in it, instead of taking the log base e, you just say you take the ln. ln is also known as the natural logarithm. So for both of these, we're just going to take the ln of both sides, because ln is equal to log base e, and then the ln will cancel out the e. So you get x equals the ln of 8,000. So then in this problem, we would use a calculator, and we would just type in ln to the 8,000, and then x will then equal 8.987. There's your answer.
Alright guys, see this is looks complex, but it's just like the other ones. You're used to seeing just x, but now we have an entire equation in there. Now, we're just going to go about the same way. We're just going to try and get this separate from everything else. So, we're going to use PEMDAS. So, because there's no addition or subtraction, but there's some multiplication when divide 6. So, you get 5 to the 2x minus 3 equals 18. Now, we're now going to take, so we can get this alone, we're going to take the log base 5, and also going to put it over here, so it's 2x minus 3 equals 18. Log base 18. Alright, so see, now it just looks like a simple algebra 2, well, algebra 1 problem. So now we're just going to actually, we would add, but I'm pretty sure you guys don't want to add log base 5 of 18. So we're just actually just going to take the change of base. And if you don't remember that, is log base 18 divided by log base 5. And you're going to get 3.4. So, like PEMDAS says, we got to do it backwards. So, negative 3, we're going to add it. So, 2x equals 6.4. And to separate x, we're going to divide by 2, and x equals 3.2. And that's your answer.
Alright, so right here we have this problem, 2 to the x equals negative 3. So we're going to have to take the log base 2 of both sides. So this will cancel out, and you'll get x equals log base 2 to the negative 3. Now this number right here is an imaginary number, so you'll have to take the reciprocal of it. So it's 1 over log base 2 to the 3. Then log base 2 to 3 equals 1 over 1.585, and then if you divide that, x is equal to 0.631.